Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following three questions without the use of a calculator. We have 5.1. Do not use a calculator to answer this question. Show all calculations. We have to prove that tan 480 degrees multiplying sine 300 degrees multiplying cos 14 degrees multiplying sine of negative angle 135 degrees all divided by sine of 104 degrees times cos of 225 degrees is equal to 3 over 2. To prove, we have a left-hand side and a right-hand side. I'm going to prove from the complex side, which is the left-hand side. So I have from the left-hand side, tan of 480 degrees multiplying the sine of 300 degrees multiplying the cosine of 14 degrees multiplying the sine of negative angle 135 divided by the sine of 104 degrees multiplying the cosine of 225 degrees. Because we've been asked not to use a calculator, I'm going to start by drawing my cast diagram in order to help in my reduction. I'm going to start by reducing it of the angle given and starting with the tan of 480 degrees. Note that 480 is more than 360. So what that means is I'm going to have a loop of 360 and then see what is left. So if I do my reduction by the side and I have tan of 480 degrees, that is the same as the tan of, I'm going to take out 360 and I'm left with the tan of 120 degrees. If I go back to my cast diagram, 120 degrees falls in the second quadrant, so therefore the reduction I'll be using will be 180 minus theta. So therefore that becomes tan of 480 will be the tan of 180. Because I'm going to 120, I need to take out 60 degrees in order to make that 120. Then I move to the next one, that is the sine of 300 degrees. If I go to my cast diagram, 300 degrees falls in the fourth quadrant, so therefore I'll be using 360 minus theta, so that will be the sine of 360 minus, to make 300, I need to take out 60 degrees. I'm going to leave my cos of 14 degrees for now to see if there's a cofunction in my denominator. And then I have the sine of negative angle. Note that in my cast diagram, if I'm reading counterclockwise, that's going to be as a positive angle. And if I'm reading clockwise, that is a negative angle. So if that angle is an acute angle, what it means is it falls in the fourth quadrant. And fourth quadrant for a negative angle will give me only cosine is positive in that quadrant, so sine will be negative. So therefore, I'm going to have that as negative sine. Then I need to reduce 135. If I go back to my cast diagram, 135 falls in the second quadrant as shown. So therefore, to reduce that is going to be the sine of 180 minus, to make 135, that's minus 45 degrees. So I'm done with cos 14 and sine of the negative angle. That's divided by. Then for my denominator, I start with the sine of 104 degrees. Now note that I can reduce 104 in two ways. That falls in the second quadrant. I can either use the 180 minus theta or the 90 plus theta. If I look at 90 plus theta, that will give me 90 plus 14 degrees. And remember, I have that cofunction hanging at the top. So therefore, I'm going to use this cofunction reduction and change that to the sine of 90 degrees plus 14 degrees times the last but not the least, cosine of 225, that falls in 2 to 5, the third quadrant. So therefore, that will be the cosine of 180 to make 225, that's plus 45 degrees. So reducing further, in the second quadrant, tan is negative, so that will give us minus tan 60 degrees times sine 360 minus 60, that falls in the fourth quadrant. Sine is also negative, so that's minus sine of 60 degrees. I leave my cos 14 degrees. Then I have times minus. In the second quadrant, sine is positive, so that's minus sine of 45 degrees. Then for my denominator, I have sine of 90. I'm going to use my cofunction here. And because that falls in the second quadrant, sine is positive. So that will be cos of 14 degrees. Times, then 180 plus 45 in that quadrant. Only tangent is positive. So that will be minus cos of 45 degrees. Now that I have this breakdown, I can use my special angle triangle to find the value of each. So starting with the common factor at the top and at the bottom, I have cos 14 degrees. Taking out cos 14 degrees, then I have my negative tan 60. That is going to be negative root 3 using my special angle triangle. That's root 3 over 1, opposite over adjacent. I'm going to write my SOHCAHTOA. That's the acronym of the trig ratio. Then I have my sine of 60 degrees. That's multiplying negative sine 60. That will give me root 3 over 2. Then I have negative sine of 45 degrees. That will be 1 over root 2. Sine is opposite over hypotenuse. I'm going to do the same for my denominator. I have negative cos of 45. That is 1 over root 2. If I take out common factors at the top and at the bottom, I have negative 1 over root 2 dividing negative 1 over root 2, that is 1. And then I'm left with, that's equal to negative root 3 times negative root 3 over 2. That is going to be positive 3 over 2, which is equal to my right-hand side. So if I go back to the question, I've been able to prove that the expression on my left is equal to 3 over 2. Let's look at the second example, 5.1.2. We had to prove that cos 45 degrees is equal to root 2 multiplying in bracket root 3 minus 1, all divided by 4. Like I did earlier, I'm going to prove for my left-hand side. So therefore, stating that, I say from my left-hand side, I need to prove that cos 75 degrees is equal to the given value on my right. I'm going to be using my compound angle identity. So if I break down cos 75 degrees, that's equal to the cosine of 30 degrees plus 45 degrees. And my compound angle rule states that the cosine of angles A plus B is equal to the cos A sine B minus sine A cos B. In this case, my A will be my 30 and my B will be my 45 degrees. So therefore, this is equal to, I'm using the expression on my right. So I have cos A sine B cos 30 sine 45 degrees minus, then I have sine A sine 30 cos of 45 degrees. I'm going to be using my special angle triangle again, such that I have cos 30. I'll put that in a bracket. That's root 3 over 2 times the sine of 45, that's 1 over root 2 minus, then I have sine 30, that's a half, 1 over 2 times cos of 45 degrees, 1 over root 2. I'm going to simplify further what I have in the bracket. Root 3 over 2 times 1 over root 2, that will be root 3 divided by 2 root 2 minus, on my right hand side, 1 times 1 at the top, 1 over 2 root 2. Note that when you're adding or subtracting fractions, the denominators must be the same. So I place that under the same denominator. That's 2 root 2. Then at the top, I have root 3 minus 1. Now I can have my sod or my roots as a denominator. So I'm going to do what I call rationalize. So if I rationalize that, I'm going to multiply the denominator and the numerator by root 2. So therefore, I'm going to have at the top root 2 multiplying root 3 minus 1 for my numerator, and then my denominator. I have 2 root 2 times root 2, that's 2 times 2, and that is 4. And note that this is equal to my right hand side. So I've been able to prove that cos 45 will give me root 2 multiplying root 3 minus 1, all divided by 2, or divided by 4. I'm correcting that. The denominator is 4. Going to the last but not the least question, and to prove that the cosine of 90 minus 2x multiplying tan of 180 plus x plus sine squared 360 minus x is equal to 3 sine squared x. So once again, I'm going to prove from my left hand side, and that is I have the cos of 90 degrees minus 2x multiplying the tangent of 180 degrees plus x plus the sine squared of 360 degrees minus x. So starting with 90 degrees minus 2x, that's 90 minus theta, that falls in the first quadrant, and using my cofunction, that would equal to the sine of 2x times the tan of 180 plus theta, or x, that falls in the third quadrant. Tan is positive in the third quadrant, so that's equal to the tan of my angle, which in this case is x. Then I have plus sine squared of 360 minus x. 360 minus x falls in the fourth quadrant. Sine is negative, so what I'm going to do is to put that in a bracket. So I have minus sine x, but because it's squared, I square that. And if I simplify further, that is going to be, I start with my sine 2x. Using my double angle identity, sine 2x will give me 2 sine x cos x times, then I'm going to use my identity to change my tan to sine of x divided by cos of x. Then I have that is plus negative sine x all squared, that's sine squared x. If I simplify further, I have cos divided by cos. I have the same factor at the top and at the bottom. I'm left with 2 sine x times sine x, 2 sine squared x plus sine squared x. Those are the same terms. There's an invisible 1 here. So therefore, that is equal to 2 plus 1, 3 sine squared x, which is also equal to my right hand side. Thanks for watching. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. Bye.